In this example, we're asked to perform the division algorithm on these two numbers, so 381 and 17, where 17 is given as the divisor. Now, I wrote it this way because I didn't want to use this symbol, but our book uses this symbol for basically applying the division algorithm. This symbol right here, this is our usual divide symbol from, say, elementary school or middle school when we first learned division. We can use this symbol as long as we interpret it right now as perform the division algorithm and not just do division as we're used to from an algebra course. So the kind of interesting thing is, though, that the best way to perform the division algorithm is to do the division that we're used to. So let's see how this works. So I'm just going to do long division like we're back in grade school. But 381 goes inside the little division house, 17 on the outside. Perform the division. So we know exactly how long division works, right? So I'm not going to talk this out too much. This turns out to be 3. So this one, no, it can't be 3. It's too much, right? So this is 2 again, 34, and then the remainder is 7. And so what we've just done here is we've got, if we go back to the highlighter, we can see that we've got our n, all right? We've got our d, this is our divisor. So the divisor goes here. What we end up getting for our quotient, the quotient is this term. So this is the q. This is the quotient of the division algorithm. And then finally, the remainder is down here, right? So this is the remainder of the division algorithm. So this is the r. And so what we end up with is that we have, remember, the division algorithm says that we can write this as n equals q times d plus r, where q and r are unique so long as r is between 0 and d, right? So unique means that there's only one answer to this. And for this one, what do we end up with then? The division algorithm says 381 is equal to 22 times 17 plus 7. Okay, so there's our q, our d, and our r. Now, this is pretty straightforward, right? But the point here is that we do not write any kind of fraction. We don't do division like we might be used to. We just decompose this number into its parts, into its quotient, divisor, remainder parts, and we leave it like this. This is the answer, okay? So this is our answer. Now, another question arises, what do we do if the number is, say, negative? So let's do another example here. Let's say I'll use the notation that I said we don't want to use, but let's say we want to do negative 51 divided by 7. Okay? Now, we know that if we tried to do this, right? So let's write this out. So negative 51 divided by 7. Doesn't make a whole lot of sense here, right? So we need a negative for sure. And then what you might do is you might do negative 7 here, and this would make a negative 49. When we subtract these, we're left with a negative 2. Right? But remember, our remainder cannot be negative. The remainder cannot be negative. So actually what you have to do is you have to go up to the next one. You have to go to negative 8, and then this would become negative 56, right? And then this subtraction now leaves us with a positive 5 left over. And so what we would say here is that negative 51 is equal to negative 8, there's our quotient, times 7 plus 5. And this 5 fits in under the rules of our remainder. So this 5 is an acceptable remainder because it is positive, or non-negative I should say, and it's less than 7. So this is a good remainder. Negative 2 would not have been a good remainder. And as we can see here, the negative symbol has to go with the 8 here. So it's got to go with the quotient. So the quotient is negative. So just be careful when you perform the division algorithm on a negative number. Remember, the divisor is assumed it has to be positive, cannot be negative. So the only thing that could be negative here is this number, and then that would result in having a negative quotient, but always a positive remainder.